Hey there, and welcome to Math with Batkins. Let's have a look at today's topic of Cartesian planes. So let's go over the basics first. What is a Cartesian plane? Well, Cartesian planes were invented in 1637 by French mathematician René Descartes, and they were named after him. What you will see in a Cartesian plane is two perpendicular lines. Now, perpendicular lines are lines that cross at 90 degrees. So these two lines here form 90-degree angles all the way around that central point. All right, let's have a look at the specifics. So our two lines that cross that are perpendicular are also called the axes. We have the x-axis, this one is the horizontal line. You have the y-axis, this one is the vertical line. The point at where they meet or intersect, right here in the middle, is also called the origin. When that is written, it is written as 0, 0. These numbers, when they're written out, can be called ordered pairs, they can be called coordinates, they can be called a number of other things. However, the only way they are correct is if they are written as the x first and the y second. Let's have a look at how you might map or graph these, however it is you're asked to do it. So the first one I have here is 2, 3. My personal preference is to go across the x-axis to the number we require. So from 0 to 2, we're going to end up there. And then we're going to go up to 3. That is where my dot would go. There are other options that are completely valid. Another one could be using your finger. So if I had 3 and -5, I'm going to put my finger on the 3, my finger on the -5, and I'm going to trace down until they meet. And that would go right there. If that works for you, fantastic. However, I find that often your finger may slip if you become distracted and you'll wind up in the wrong column, at the wrong number, at the wrong location. Your fingers won't actually line up. One hand goes faster than the other. Oh, could be lots of different things. However, there are lots of different ways to solve things. The final bit to have a look at is what happens if it's at 0. So if the x number is at 0, you will find that it will remain on that vertical y-axis because x doesn't go anywhere. So if x is 0 and then we're going to -2, we're just going to go down to -2, and that is where 0, -2 would be. However, if it's the reverse and we're going -2 then 0, first we have to move to -2, and then you'll find that horizontal x-axis line is where a y0 number would end up, and it would go here. Now, each of these 4 sections around the Cartesian plane are called quadrants. You may be used to working with this first one here, also known as quadrant 1, because that is the first one you learn. It is our positive numbers. It then goes in a anti-clockwise direction, making this one quadrant 2, which has negative positive numbers. This one over here is 3 with negative, and the final one is 4 with positive negative numbers. As I said, it's that anti-clockwise direction, and that is our 4 quadrants and the Cartesian plane. Final thing to look at are some pressure points. The scale on this one is 1. So each of these boxes increases by 1. We have 0, 1, 2, 0, -1, -2 in both directions. Sometimes our scale can change and it may go up in 2s, in 5s. You may have the x-axis increase by one number and the y-axis increase by another. These are all perfectly fine. You just have to make sure to check your scale first to ensure you don't have to go between boxes. For instance, if this were 1.5 and then 1, you'd be going halfway through this x-axis box. Sayings. I love a good saying that's going to get stuck in your head to help you learn things. So X first, always X first. y to the sky or y goes high, so remember that your y is your vertical axis. And the final one I have is all about your drawing, whether you're going to link your dots with lines or to make a hidden image, is dot, dot, line. So let's have a look what that may look like, because that is very handy. So I'm going to start at -5, 6. I'm going to use my preferred method of going across the -5 up to 6. There goes my dot. Then I'm going to go -5 and 1, so across to -5, down to 1. Here's my second dot. Now I'm going to get those joined together with a line. You would, of course, use a ruler. Crazy. Then our next number is 1 and 4. We're going to cross to 1 and up to 4 and put a dot there, draw in our line, and then we're going to go to -5 and 6. I assure you my little dotted line is there, you just can't see it. And because we already have a dot there, we can just rule the line across and our shape is finished. Now, as you do one of those, it's very easy to get lost. You should check them off as you go. Now, there are options when doing that as well, and it is a personal preference. However, crossing them out means that if you make a mistake, you have to go back and erase every single one of those. So I've crossed it out because I've done that. Oh no, I've made a mistake. Here I come. I've erased it. However, if you tick them off as you go and give them just a little tick or a line, if you make a mistake and come back through, all you have to do instead of erasing is go the opposite direction, and you'll find you're able to keep track of it a lot easier, and you're not going over the numbers that you have to graph. One of the last things we're going to have a look at is how you would write them down. So if I have to look for that green dot, I'm going to do it in reverse. I'm going to go from the green dot to the x-axis. So I know that that's going to be a 5. And then I'm going to go from the green dot to the y-axis, and that's a 3, so that one would be 5, 3. And if I were to look at the orange dot, I'm going to go up to the x-axis to 2, and then across to our y-axis to -2. Again, you could use your fingers and go up to the lines and have to remember your x and y's still. There are lots of different ways to solve problems. As I always say, you don't have to solve it my way. You just have to get the same answer as me. Later, peeps.